Hello, geometry students. My apologies if you were unable to get onto the live review yesterday, but I'll go through the problems again today. What I would advise is as you get to each slide that you should try to answer the questions before I go through them, and then hit resume playing and you can check your work as I go along. So here's our first slide, and it's just going over some of the vocabulary from the chapter. So first of all, it says, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent of circle P. So if I look at this first one, it's asking me about segment PK. So PK is going from a center to a side. It's a segment. So I would best describe that as a radius. Our next one is NM. Notice it's a segment, not a line. So NM is a segment with 2 points on the circle itself. So that is the vocabulary term known as a chord. On the next one, we have ray JL. Ray JL, let's see here. So JL, look, that's this ray starting at J and going through L. If I look, it's touching the circle at one point here, right there. So if you have a ray or a segment or a line or a, I guess that would be it, touching a circle at one point, we call that a tangent. Next, we have segment KN. So starting at K, going to N. It is a chord, but it's a very specific kind of chord. It passes through the center. So a chord that passes through the center of a circle is known as a diameter. All right, next we have line NL. So this time it's a line. It's a line passing through a circle. We call that a secant. And number 6, segment PN. Segment PN starts at the center, goes to one side. We call that, again, a radius. All right, next slide. This time we are supposed to identify whether this is the tangent is internal or external. So the easiest way to tell whether tangent is internal or external is to join a segment connected to the centers of the circles. So I have this circle here. If I draw a segment that connects to the center of the other circle, I can see that the tangent line intersects it. If the tangent line intersects the centers, we call that an internal tangent. All right, if I look at number 8, again, I'm going to join the centers of these two circles. And this time, if I look, the tangent does not intersect the center of the circle. So this would be an external tangent. All right, next slide. This time we're asked to find the value of x. If you notice, we have this segment AB that's tangent to the circle and segment AD is tangent to the circle. And if you have two tangents that connect at the same point outside a circle, these two tangent segments have to be equal to each other. So I'm going to set this problem up as 5x minus 4 equals 3x plus 6. I'm going to solve for x. I'm going to subtract 3x from both sides. So that gives me 2x minus 4 equals 6. I add 4 to both sides. So that gives me 2x is equal to 10. And if I divide both sides by 2, I get that my value of x is, get it right on there, x equals 5. All right, in our next review question, let's see if I can move this out of the way here. This time we're asked to tell whether or not segment AB is tangent to the circle. So in order for AB to be tangent, it would have to be perpendicular to the circle at the point of tangency. So that would mean that this segment right here would have to be meeting segment AB at a right angle. So what I'm really looking to see is this a right triangle? So in order to tell whether it's a right triangle, I'm going to use the Pythagorean theorem. So I know one side is 48. I know the hypotenuse is 52. To figure out the length of this side here, let's see, it looks like I know a radius is 10, and that means this piece right here would also have to be, let me get my pen. This part of it would also be 10. So when I'm using the Pythagorean theorem, I want to check, is 48 squared plus, and it's not 10 squared because each of those radii is 10. So the diameter is 20. So is 48 squared plus 20 squared equal to 52 squared? That's what I'm trying to check. If it is, then I know it's tangent. So if I do 48 squared, I get 2304 plus 20 squared would be 400. And I want to know, is that equal to 52 squared? So if I do 52 squared, I get 2704. So is 2304 plus 400 equal to 2704? Yes. So that means that AB is perpendicular to the radius. I'll just say it's perpendicular to CB. So that means AB is tangent. And again, to check that it was tangent, I checked to see whether or not a right triangle was formed by those sides and the diameter. This time we're trying to find the measure of each arc. Again, be sure to try these on your own before you just copy them down from here. So the first one, I want to find the measure of arc KL, this arc right here. So again, in this unit, remember, we were looking at central angles. So I have a central angle measure of 100, which means its intercepted arc is also 100. So KL is going to have a measure of 100. Okay, next I'm looking at arc LM, this minor arc right here. Okay, to figure out this one, I can notice that segment LM is a diameter, which makes this arc that passes through these 3 points, NML or LMN, is a semicircle, which means it's 180 degrees. And if I have a central angle of 120 degrees here, that means that this angle right in here must be 60 degrees. And if that central angle is 60 degrees, then that means its intercepted arc, LM, would also have to be 60 degrees. Okay, next I'm looking at arc KM. Excuse me, that's the arc starting at K and going all the way to M. It's still a minor arc. right? It's less than 180 degrees. I have a central angle of 100, a central angle of 60. If I add those two together, I get 160. So arc KM has a measure of 160 degrees. Okay, lastly, we're looking for the measure of arc KN. That's this missing piece here. If you look, we already know these three angles. So again, I could add them all together, subtract them 360, or you can look and remember that LN is a diameter. So that means this is a semicircle. We have 100 degrees here, which leaves us for this central angle a measure of 80 degrees, which means its intercepted arc down here, KN, is also 80 degrees. This question says, tell whether or not the red arcs are congruent. Explain why or why not. So there's two things that are going on here in order to figure out whether arcs are congruent. They have to have the same degree measure. So if I look at this arc and this arc, they both have the same central angle. So like this angle is certainly congruent to this angle because they're vertical. So it would seem that maybe these arcs have the same measure, but the only thing that's making them not congruent is the fact that these two circles are not congruent. So they have to have two things. They have to have the same degree measure, but they also have to be in congruent circles. So are the red arcs congruent? My answer would be no. And my reason would be that the circles are not congruent. On 23 and 24 here, we have find the values of the variables, right? This time we're looking at, well, on question 23, we're looking at an inscribed angle. So this is from section 10.4. Inscribed angles have half the measure of their intercepted arc. So if the inscribed angle is 40, that means the arc measure is double that. So the arc measure for X is 80. On 24, this time we have a quadrilateral inscribed in a circle. We had a theorem that said if you have a quadrilateral inscribed in a circle, that the opposite angles were supplementary. Remember, supplementary again means they add up to 180. So if I look at Q and 80, those two together have to add up to 180. So that means that Q would have to be equal to 100. And on these two angles, F here and D, these opposite angles have to be supplementary. So I already have 100 degrees here, which leaves me for 80 degrees for this angle down here. So that would give me that 4R would have to equal 80 degrees. If I divide both sides by 4, I get that the value of R would be 20. All right, on 25, I have to look at, well, let's see, I have this angle here, angle KML is 70 degrees. And I'm going to switch pen color here so it's a little easy to see what's going on. I'm going to go back to red. So if I look at that angle KML, it is intercepting this arc right here. This arc KL, see if I can go right along that arc. All right, so I know that that's 70 degrees, which means this arc is 140. If I notice this angle here also intercepts that same arc, which means if this is 140, then 14D would have to be equal to half of that, or in other words, 14D has to be the same as this angle. So I can mark these two angles actually have to be congruent because they're intersecting the same arc. So to solve this problem, I'm going to write that 14D would have to be equal 70 because they're both intercepting the same arc. I divide by 14 on both sides. And I get that D would have to be equal to, should be 5, right? Yeah, okay. Number 26. Right, this time we have a triangle inscribed in a circle. If we notice, the longest side of the triangle is a diameter. And anytime you have that, where you have the longest side of a triangle inscribed in a circle as a diameter, that means this has to be a right triangle. So I'm going to put the little right angle symbol right here in this corner. So angle P is a right angle. So if I want to figure out what y is, I'm going to write 3y equals 90. If I divide by 3, that gives me y is equal to 30. All right, so far we have that this angle here, we just said was, I'll draw a little arrow, that's 90 degrees. So we have 90 degrees, we have 50 degrees for a total of 140 degrees. Remember, all three angles in a circle add up to 180. So if I have 140 so far, that leaves me for this angle down here, I have 40 degrees left. So that would mean that 4z, I'll write it down here, 4z equals 40. So z is equal to 10. All right, number 27. Seems like a lot going on there, but it's not that bad. So I'm going to look here. I have this angle down here, 39 degrees, inscribed angle, 39 degrees. It's intercepting arc RS. So if I look at the figure, I have another angle that intercepts arc RS, and that's this angle down here, angle N. So that would mean N has to be the same as this angle, right? They both intercept the same arc. So that gives me that N is equal to 39. All right, I also have this 44 degree angle right here, right? 44 degrees. It intercepts this arc BT right here. And if I look, this angle right here, angle VRT, also intercepts that same arc BT. So that means M has to have the same measure as 44. And so I'm going to write M equals 44. All right, if I look at number 28, it's just a pretty straightforward inscribed angle. I know it intercepts an arc that's 56 degrees, which means angle C has to be half of that. So C is equal to 56 divided by 2. That means that C is 28 degrees. All right, now we're on to section 10.7, where we're writing the standard equation of a circle. Hopefully you recall, I'll just write it here at the top, that the standard equation of a circle is x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. Okay, we have a shortened version of that. If it's centered at the origin, we just have x squared, let's see if I can get this to right, plus y squared equals r squared. So that's centered at the origin. So those are kind of handy when they're that way because you don't have the minus h and minus k. All right, so for each of these, I'm first going to find the center, then I'm going to determine the radius, and then I'm going to write the equation. So in this one, and be careful, you have to look at what the scale is of the graph. So it looks like this, I'm going by ones, so I'm okay. So my center is the point 4, -1. My radius is equal to, let's see here, I can count 1, 2, 3 squares. So my radius is 3. So my equation turns into x minus 4 squared plus, and remember you do the opposite of what the sign is, so this is going to turn into y plus 1 squared equals the radius squared, and if the radius is squared, 3 squared is equal to 9. All right, number 38. This time looks like my scale is going by 2s. So I'm going 8 to the right and looks like 2, 4, 6 up. So my center this time is 8, 6. And this time the radius. And remember, I have to look at what the scale is. We're going by 2, so the radius is 2, 4, 6. So to write my equation, I'm going to have the quantity x minus 8 squared plus y minus 6 squared equals 6 squared, which is 36. All right, on 39, this time we have a circle centered at the origin, so that's handy. Looks like we're going by 2s on the graph. All right, so our center this time is the origin, so 0, 0. Our radius, we're going by 2, so it looks like we're going 2, 4 units. So our equation turns into x squared plus y squared equals 4 squared, which is 16. So move that out of the way. Okay, this time we have some circles where we don't have a picture and we have to come up with the equation. So it says, write the standard equation of a circle with the given center and radius. All right, number 40. The center is 0, 0, radius is 9. We're going to have x squared plus y squared equals 9 squared, which is 81. All right, number 42, this time that the center is at 621. So I write x minus 6 squared plus y minus 21 squared equals 4 squared, which is 16. Hope you guys are doing these and getting them right. Again, if you're having trouble on these, be sure to email me with your questions and I can answer them. All right, number 43, center is at negative 3, 2. So I have x plus 3 squared plus y minus 2 squared equals 16 squared, which is 256. I think we just have one more slide today. Yep, we have the point negative 7, 1 is on a circle with center negative 7, 6. Write the standard equation of the circle. All right, so on this one, switch it up here. Let's go with blue. So in this one, we know the center. So I can start out by writing x plus 7 squared plus, and again, I'm looking over here at the center. Right? So in this parentheses, I'm going to have y minus 6 So I have to figure out the radius. Now I could have plugged this point in for x and y. We had some examples where we did that in the notes. I could have plugged in x and y. I could also graph this. But this one, I think it's just as easy to look. If I go from the point negative 7, 1 to the point negative 7, 6, how far away is that? How far is 1 from 6? right? Hopefully you said it was 5 units. So that means my radius is 5, right? To go from 1 to 6, I've gone a total of 5 units. So my radius is 5. So this equation turns into x plus 7 squared plus y minus 6 squared equals 5 squared, which is 25. All right, number 48, prove or disprove that the point 4, -3 lies on the circle centered at the origin containing the point -5, 0. All right, well, let's see. Let's just look at this second part. All right, I want to just see what would this equation, I'm just going to circle this whole thing. Whee. Let's see what that equation would look like. So I'm going to write x squared, we're centered to the origin. So x squared plus y squared equals, right, we're centered to the origin. That's how I knew it was x squared plus y squared. And if I go from the origin to the point -5, 0, if I go from here all the way to there, I've gone a total of 5 units. So my radius here is 5. So my equation would look like x squared plus y squared equals 5 squared, which is 25. Right? So I want to know now, is this point on that equation? Well, in order for it to be on that circle, it would have these points x and y would have to satisfy this equation. So let's see if that's true. So I'm going to switch up my colors here. So I'm going to put in 4 for x, -3 for y, and see if it's true. So I'm going to put in here 4 squared plus -3 squared. And I want to know, is that equal to 25? All right, so I'm going to check it out. Is it true? So is 16 plus 9 equal to 25? That's what I'd like to know. And if I add 16 and 9, I get 25. So yes, 25 equals 25. So is the point 4, -3 on the circle? My answer is yes. All right, and where it says prove or disprove, all of this work down here is our proof. Okay, that concludes our review. Hopefully you got something out of it. Again, your test is probably going to be either Thursday or Friday of next week. I will post it on Schoology and let you know. Go through this review. If you have any questions, you can email me. Thanks for being here today.